You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Okay, for Eyal, Harel, BlueGreen Water Technologies. So the big takeaway here, I realized, is bodies of water, lakes, oceans, bays, etc. Cyanobacteria exist in all of them, and when they're fed nutrients like nitrogen and phosphorus, they can bloom suddenly. So BlueGreen has a technology where they're figuring this out before it's even a crisis, which is great. But it's funny, what really struck me is just like a kombucha, or sauerkraut or any fermented food or a yogurt, you have one bacteria or a couple kinds of bacteria that get in there and establish their own environment and acidify it or make it conducive to them, and that keeps out other bacteria. So what can happen in a body of water or a lake or a part of the ocean is that these cyanobacteria are getting fed probably by runoff from agriculture and other stuff, and all of a sudden they're proliferating and they're elbowing out everyone else in that ecosystem, and they're making it conducive for them, but unfortunately it can kill everyone else that wants to be in that body of water, other fish, other bacteria, etc., and other people and animals that want to drink from the water, bathe in it, sit near it and breathe it and everything. So that was a big takeaway. I realized, whether, again, you're making a yogurt or a kombucha, or in your own gut, there's bacteria that can predominate and cause you problems and destroy your gut microbiome, or a lake or an entire ocean. I mean, this is like a fractal concept that exists at all these levels. So that's one big takeaway from them.
Hello, this is Richard Jacobs with the Future Tech and Finding Genius podcast. I have Eyal Harel. He's the CEO and co-founder of BlueGreen Water Technologies Ltd. So, Eyal, thanks for coming. How are you doing today?
Thanks for having me. Doing great.
Yeah, tell me about BlueGreen. What's the premise of the company?
So, BlueGreen developed the first solution to harmful algal blooms in large scale.
Oh, algal blooms. Do these happen in just the ocean? Do they happen in freshwater, or where do algal blooms happen? And let's talk a little bit more about them.
So toxic algal blooms happen all over the world in sea, in freshwater, in lakes, irrigation, reservoirs for irrigation, aquaculture. Everywhere where there's water, you'd find toxic algae. The question is in what quantity. Under healthy conditions, cyanobacteria, which is a photosynthetic microorganism that releases toxins into the water, is under control through checks and balances with other species in the environment. When the environment is disturbed because of human intervention, but not only because of many parameters, including temperature, nutrients in the water, other factors that may influence how much and how fast they grow. Under these conditions, this very fragile balance is disturbed, causing the toxic species to overpopulate, sort of a population explosion. And as a result, they dominate the entire ecological sphere. And when that happens, they continuously change the conditions in the water, the chemistry of the water and the biological mix in the water to their benefit, to the extent that they completely dominate the water body. Now, this situation has very, very bad implications in every parameter. To begin with, environmentally, it's a very bad situation. Other species cannot properly coexist an overpopulating bacteria in the water, toxic bacteria. It affects the ability of other organisms to breathe in the water. They deplete the oxygen in the water. They cause a very thick layer of scum to be formed at the surface of the water, so everything underneath is blackened and again doesn't get enough oxygen or light as needed. It's an environmental catastrophe in a sense. And then you have the toxins.
Oh, I was going to say before you go on, this is really interesting because I've done a lot of calls on, for instance, the human microbiome. And I've done calls on people that do fermentation. They'll make kombucha and, sauerkraut and things like that. And it's the exact same thing. One species, there's certain conditions that allow a species of bacteria to predominate. And that causes a problem with the water body, or it causes a problem in your gut, or it causes a problem in even something as simple as making, like, again, a kombucha, and it gets ruined. So it's just so funny to me that this happens at all levels and all scales, and there's a lot of similarity to what I'm hearing so far. So I just wanted to mention that.
That's true, and actually it makes total sense because it's bacteria, and bacteria behave like bacteria under the right conditions. So when you have a sick lake, it behaves like a sick person. So when the person is under the influence of an aggressive bacteria, then you have to deal with the bacteria, normally with antibiotics. When a lake is sick, with the overpopulating bacteria in the water. And unfortunately, until today, this the efforts to curb this massive onslaught of bacteria on these water bodies have failed colossally. And if you look at this internationally, and this is not just a U.S. problem. It's all over the place. It's everywhere, including places that you would think are, let's say, much more vigilant in terms of environmental control and control of runoffs into lakes and so on and so forth. Take Europe, for example. Europe is suffering tremendously from algal bloom. I'm not even talking about China, Africa, everywhere. You have very bad algal bloom. And the reason is that these guys have been basically multiplying uninterruptedly, not just in the last couple of years, for centuries. And it's true that the last decades have been detrimental in the sense that much more human activity and fertilizers in the agriculture and other sorts of runoffs, as well as natural activities. And I'm not even talking about global warming, all combining into the already beneficial conditions to become perfect, to create basically the perfect storm in terms of bacterial infection. And that, sorry?
Yeah, question here. So in a healthy body of water, what place do cyanobacteria have? Are they in very, very small numbers? Or, how would you rank them in terms of representation of the population? Are there still a lot of them, just not dominating, or what's a healthy body of water look like?
Yeah, exactly. I mean, cyanobacteria is one of the cyanobacteria is one of the building blocks of life on Earth as we know it. It's the forefathers of algae, which is the forefathers of aquatic plants, which are the forefathers of grass and trees and everything we know it. So cyanobacteria has been around basically since Earth, and it's everywhere. It can be found in the Arctics, it can be found in the deserts, it can be found even when there's no water, and it's just everywhere. And yes, and under healthy conditions, it is controlled by other species that are basically feeding off the same resources. So if you think about the savanna in Africa, you have a healthy number of lions and a healthy number of zebras and a healthy number of leopards, and they all coexist. And if one gets out of control in terms of numbers, then it influences all the rest because resources, in the end of the day, are limited, and this is the result.
So again, in a healthy body of water, what percentage of the bacterial constituent are cyanobacteria? Are they in very small numbers normally, or are there still tons of them? They're just not dominating and pushing everything out.
So per watt. Then you
Right.
need to see
What would be
what would
when
be
you
the reference.
evaluate water?
So
Right.
yeah, so
Exactly.
there are international standards. So the reference in terms of what constitutes a bloom, the international figure is 20,000 cells per milliliter. That would raise a warning. So under normal conditions, they will be well below that. Under bloom conditions, they'll be in the millions and in the billions and in the trillions. And that's when you see the thick scum forming on the water, very very thick, a turquoise color of the water. Basically, you probably have seen the phenomenon. It has received a lot of attention in Florida and in Ohio, Lake Erie, and so on, in Lake Okeechobee. When they show images, satellite images of Lake Erie and the bloom that is forming in Lake Erie, you effectively see bacteria from space. I mean, just get your head around that. You see bacteria from space. So you can imagine what numbers can result in something as amazing as that.
In a healthy body of water, what is the most prevalent bacteria that's observed above and beyond cyanobacteria? Are there other ones that are super prevalent that they're displacing, or is there no one bacteria that seems to dominate?
No, and don't get me wrong, cyanobacteria is not a bacteria. It's a family of bacteria. So there are different members of the cyanobacteria family, and there are different members of many other photosynthetic microorganisms that are in the water. Generally speaking, any water body is a biological jungle, and it changes all the time. So if you would take a water sample from a lake and take another sample from exactly the same place 5 minutes later, or 2 feet to the side, or 1 foot below, you'll get completely different results in terms of species variety and sometimes even water chemistry. So this is a very, very tricky environment to work because it changes very fast all the time, and it's moving. You have currents, you have winds. The whole system is on the move. There is a lot that's going on in the water which we cannot see. Which is why I'm always surprised, when people are complaining that they have suddenly there's a bloom in the water. It's not suddenly. And normally, when they think that they suddenly saw the bloom, when they see a bloom, it's already, it's already in a catastrophe mode. It means that the bloom was already there long before. You remember I said before that the threshold for warning in terms of blooms is 20,000 cells per milliliter. Now, 20,000 cells per milliliter is clear water to the naked eye. So when in Lady Bird Lake in Austin, the way they wake up in August to a bloom suddenly, it's not suddenly. There was probably a bloom last year as well. They just didn't know it. Nobody checked the water. But there was a bloom, and it developed and developed and developed. And while it was last year, it was only in the hundreds of thousands, and they couldn't see it. Now it's in the millions or the billions. That's the difference.
All right. So what are some of the ways that you found that can clear up a body of water?
So fundamentally, again, this is a very complicated problem. And the main, most pronounced aspect of it is the sheer number of bacteria in the water that doesn't allow other species to serve their natural role within the ecosystem. And what we have done, we've created essentially an algicide that under very, very small dose regime and a very, very simple treatment protocol creates a situation. I don't want to go too much into technical aspects unless you're interested in hearing all the technical aspects.
No, I do. Yeah, I do want to. Well, one thing I'm considering as you're talking is even a small body of water has so much volume in it. So if you were to let's say you were to put a chemical in to try to treat this, unless that chemical worked at tiny, tiny concentrations, I don't know how you would ever, change a body of water's chemistry. It seems like you'd have to take a biological approach and alter the cyanobacteria or introduce some other species that would, cause them to die off. Because that's just my thoughts on the scale of the problem. But let's go into some technical details. Tell me.
No, so you're spot on. You got it. You got it exactly right. That's the reason why algicides to date haven't worked other than in very, very small scale in huge quantities, because you had to shock an entire water body, usually small ponds of a couple of acres, but still you had to shock treat them with massive quantities of algicides in order to get an effect. You're absolutely right. The thing is, what we've done, we've taken the same algicides that have been used in the past, but we manipulated them. We changed their formulation with a very small input to allow them, we changed their physical properties to allow them to float and time release, which means now we don't need to shock treat the entire water body. The application is very simple. You apply the product upwind. The winds and the currents do their thing and push the product along the same movement patterns as the target, as cyanobacteria. So you have a perfect movement, a perfect match between the movement of the target and movement of the algicide. And the algicide is where it needs to be and also when it needs to be, because the whole system moves together. Now, this is just the chemical aspect. So now what we've managed to achieve is to bring the chemical to the target like a silver bullet, where it is and when it is. By doing so, we're able to trigger a biological chain of event, and this goes back to your question, that exponentially expands the initial result of the algicide that we're using. What do I mean? When we're using chemical in the water in the right amount and over a sufficient period of time, cyanobacteria starts releasing signals into the water and create a secondary oxidative stress. This is what I'm telling you right now is completely natural and specific to cyanobacteria. Okay, that's the second phase after the chemical application. So at this point, we start a biological chain of events where the cyanobacteria starts releasing signals into the water that are being broadcast throughout different layers, including to naive populations of cyanobacteria, causing them to undergo a programmed cell death, meaning the entire cyanobacterial population, or in large quantities, is basically committing suicide, if you wish. And what we've seen through thousands of commercial applications is that within 24 to 48 hours, we've been able to decimate cyanobacterial numbers by 90, 95, 98%. It's that fast and that dramatic, and it has nothing to do with the very, very small quantity of chemical that we've introduced into the water. So this is very dramatic, but this is only phase one. So the first step is to crush the numbers of cyanobacteria in the water. Now the second phase, again, completely natural, because within a couple of hours, there's no chemical in the water that is creating any sort of effect. But what we are seeing over time, and I'm talking about days and weeks following treatment, we see that following the dramatic decline of cyanobacteria, we see a dramatic increase in the numbers of beneficial species. So we are rehabilitating the lake in the sense that we allow the natural competitors of cyanobacteria, the non-toxic species, to reoccupy the ecological niche. And from now on, they serve as the biological, if you want, grass mower that will prevent or at least delay the cyanobacteria from resurge again and become dominant, and that can take them from there on, can take them months and sometimes years.
What happens to the 10 to the 50th corpses of cyanobacteria as they die and probably sink to the bottom? That would change the environment of the floor, the sea floor, the ocean floor, the lake floor. And what would be the consequence there?
Okay, so if you want to take the environmental approach, you should not wait for a bloom. Don't wait for a catastrophe. So stop the bloom before it even happens. And this is what we're trying to preach to all of our clients. Hit it when it's small, because when cyanobacterial numbers are low, when they are at the 20,000 level, or even 50,000, or even 100,000 level, the amount of chemical that you'll have to apply is ridiculously low. The effect is just as pronounced, and you prevent a situation where you have lots of corpses, so to speak, in the water. Now, it's true, if it's already a catastrophe, then under a catastrophic situation, the result is that you have lots of corpses in the water. And when you have lots of corpses in the water, again, totally by a natural a process takes place where you have bacteria that's their role in the environment, to eat off the corpses. And that's what's going to happen. By the way, one of the reasons why you have oxygen depletion in under bloom conditions is that these bacteria that eat the corpses, they consume a lot of oxygen, which depletes the oxygen in the water. Now this happens anyway, whether you treat or not, because bacteria multiplies, but it also naturally dies. So if you don't treat, you'll still have masses of corpses building up, but the masses that are alive will continue growing. So you're not saving on corpses if you don't.
Makes sense. What's the predominant nutrient source for cyanobacteria, and what metabolites do they create that rise up to tremendous levels in addition to just the bloom of the bacteria themselves? I'm sure they're producing certain metabolites that are getting to tremendous levels in the water as well. So again, what do they feed on and what do they produce?
Right. These are two separate, very important questions. They eat primarily, if you can call it eat exactly, they eat primarily phosphorus and nitrogen. And these are available in different levels in different water bodies. They are not the only source of food, so to speak, for cyanobacteria. Other sources are sun and many other aspects in the water that would create, let's say, comfortable conditions for cyanobacteria to thrive. For reference, there's been a recent publication in Nature magazine where they have shown that it's difficult to show correlation between the amount of nutrients, i.e. N and P, in the water and the level of bacteria. On the other hand, there is a much better correlation between temperature and the amount of bacteria in the water. So again, it's a complicated matter, and they can feed off different things. And even if they are stressed and there are lower levels of phosphorus, for example, some species of cyanobacteria know how to scavenge phosphorus from neighboring species. So they're quite resourceful. In terms of metabolites, also very important, they release lots and lots of different metabolites into the water. Many of them are very, very toxic, including some of the toxins can hurt the brain, neurotoxins, liver toxins, dermal toxins, toxins that can affect the digestive system. And the problem with that is that science knows only a few of them. So every year they find a couple of new metabolites that are dangerous to the animal, and they publish those. But normally what happens is that under bloom conditions, the local authority, if they know about it, and they only know about it because residents reported that they've seen the bloom. And again, that means that it's already a catastrophe in terms of numbers. And that's when they'll send somebody to take some samples. The samples will come back after a couple of weeks where, as I mentioned before, the results will already, the conditions in the water have already changed several times. But then the lab results in terms of toxins will only check, usually they check less than 8 specific toxins in the water. So in principle, what can happen is that they can return negative results. In other words, they can argue that there are no toxins in the water, that the water is safe, but that doesn't mean that the water is really safe. It means that they didn't find the toxins they were looking. And this is where it's becoming very, very problematic when under bloom conditions, local authorities are waving a flag saying, no, everything is okay, you can use the water regularly, because you know what, I would.
Okay, so if I'm looking at a body of water and I have algal bloom, let's just say it's a circle and it's half a mile in diameter, would I drop in your solution in the center of the circle or the edge? And or does it depend on the currents and the wind? And have you had situations where the bloom is split into multiple blooms, which makes it worse? Or Like, what does it look like from a concentration of bacteria at an eye level and a health level as you treat?
So yes, and yes. Again, if you look at blooms from satellite images of blooms, you'll see there is no rule of thumb. Basically, the movement of the bloom is very much dependent on the winds and the currents. There are certain hotspots where a bloom would usually start, so to speak, in shallower, warmer waters. But from there on, it would just, like I said, it will move with the currents and the winds. They don't swim. They are being pushed. So in terms of treatment, we would do exactly the same. We'll follow the pattern of the winds and the currents and apply upwind, upstream, and let nature do the rest. We've treated in places where we were very limited in terms of application location. We had to drop the compound from a single suboptimal location, but it didn't matter much because eventually, the wind changed and pushed it in the right direction. This is the whole beauty with the whole thing. You don't have to follow a very strict, definitely not a full lake application. The beauty with the application is its simplicity. You can do it in a your example of half a mile of a lake. It's easy. You just you get from the banks of the lake, or from a boat if you want. And in larger areas, you can also treat it with the planes in Israel. We have quite a few customers that drop the product from a crop duster. So there are many ways to do it. It's very, very easy. More importantly, it's very fast to respond. So if you see a bloom, you don't need to, call the cavalry and, wait for weeks for them to bring, special equipment and special personnel and prepare and all this, because again, time is of the essence. These things these bacteria are multiplying on an hourly basis. The ability to bring the product to the lake and apply it fast is key. To give you a reference, we treated the Chippewa Lake in Ohio. It's a 330-acre lake. We treated it in the beginning of August. Now, this lake has been badly hit by cyanobacterial blooms since 2014, they would have to close the lake for any use every year since between April and November. We treated it in the beginning of August. It took us 25 minutes to treat 330 acres. Results were obviously within 24 hours. The number of cyanobacteria dropped within 24 hours. The lake was open to the public that afternoon, and it stayed open to the public until today. I'm guessing that by now the lake is already frozen. But again, last year, until I think the end of November, it was closed to the public because of very heavy blooms. It was clean ever since we treated it. So the treatment is easy, fast to apply, and the results are very much long lasting.
Yeah, I was going to ask you, once a body of water has an algal bloom, is it more likely to have more of them in the future? Is there even data on that? Or once you treat, is it seen to be protected for a long period of time more than it normally would?
So if a lake has an algal bloom problem, whether there will be next year, whether you will have another cycle of a bloom is practically a guarantee, because what happens during winter time, and really what authorities are thinking to themselves, okay, we'll wait long enough that will collapse. It's true and not true. You will not see the bloom anymore under unfavorable conditions, for example, winter, low temperatures. The bacteria simply feels uncomfortable. They go down and they wait. They don't go anywhere. Again, remember, they have been multiplying for many, many years. The reason that you see now what you're seeing is that they kept ramping up their numbers to the point that now it's a catastrophe. So if you don't treat, then next year you'll start from a higher level, which is why all over the world you see an intensification of blooms worldwide, because they are untreated. Now, when you do treat, if you are able to effectively reduce their numbers dramatically, then in a way, you're resetting the situation. So next year, instead of starting at a much higher level, they are starting at a much lower level. And therefore, their ability to gather strength is substantially diminished. They are now facing again with enhanced competition from other microorganisms that compete on the same resources. So the overall conditions for a bloom to form is far reduced, and the overall condition in the water is much better.
Interesting. Are you studying the dynamics of quorum sensing in bacteria to help you figure out how to make the treatment even better? Or do you feel like it's at a level where it's good enough, and now the key is to get it deployed quickly when people need it?
So the treatment that we've developed is the result of these studies. So the originators of the technology are Professor Aaron Kaplan from the Hebrew University and Dr. Moshe Harel, who was his PhD student. And they specialized in the communication between bacteria. It's not a coincidence that the treatment was designed not to be a chemical treatment per se that kills with a 5 kilo hammer dropped on the heads of the bacteria. The idea was to very selectively, surgically hit the bacteria in a way that will trigger these communication, these signaling system within the cyanobacteria, specifically within the cyanobacterial population, to create an effect that is selective to the toxic species and doesn't affect the rest of the microorganisms in the water.
So what's next for this treatment? What do you see as important to do from here to make it even better?
So basically, our first two products are already US EPA approved. They are commercially available in the United States. We only launched late 2019 our first product. The second one will arrive hopefully by the beginning of 2020. We hope to start pushing this solution as far and wide as possible across the country. At the same time, we're working in other countries, in China, South Africa, Russia. We're very much working in Israel, including with the Israeli National Water Company. We didn't really go into the, other than the environmental aspect, we didn't really go into the humanitarian aspect of contaminated water and how they affect people all over the world. But this is really from my perspective at least, the real driver to push this solution as fast as possible into the market. Because when Lake Erie was blooming in 2014 and the water system, the drinking water system in Toledo collapsed, then the governor of Ohio declared an emergency, state of emergency, called the National Guards, and they started, giving out water bottles in the streets. When something like that happens in Africa, and it happens all the time. I was recently in South Africa where it was published in a newspaper that water coming from one of the biggest dams in the country was arriving the end users with earthy smell and taste. And this is textbook cyanobacteria. And it's also textbook that the water treatment facilities are failing. And the authorities' response was, we know there is a bad cyanobacterial bloom in the dam. Everything is okay. You can drink the water is safe. That was the response, was media. And my first response was shock. How can the local authorities tell the people that the toxic water that comes out of their taps is safe? But then I was thinking, what's the alternative? What can they do? There's no National Guard to call and start, handing out in small village bottled water, right? So the alternative to sounding, the no alarm signal is, causing panic, and that's what it all boils down to. The fact is that resources are diminishing. There's, global warming, less rain in many places around the world. The reduced water levels are further catalysator for warmer temperatures in the water and even more intensified blooms. And people are left without water to irrigate their crops. It's a catastrophe. I mean, it's a catastrophe with biblical proportions. And this is why I'm hoping that that we can bring out this the message that this is not something. This is not an act of God that cannot be handled. This is not a hurricane. It's something that can be treated. We're treating today lakes all over the world with 100% success, and it's fast. The results are within 24 hours. It's that fast. And it's very, very important for us to deliver this message all over the place.
Yeah, well, I wanted to ask you, what happens if you attempt to drink water that has, trillions of cyanobacteria per milliliter? What are some of the health effects? Or is it even drinkable at all?
To start, you can die. But it's not just if you drink. Look, it affects everything. The toxins become aerosol, so you breathe the toxins. You drink the toxins if you drink the water that is not properly treated. Eat the toxins because if you eat fish that grew up in toxic water, then the toxins accumulate in the fish organs, and then you eat it. If you eat crops that were irrigated with toxic water, then again you eat toxins. So this is not just a problem of people that are directly next to infected lakes. It's they are being affected hardest because they suffocate from the stench, they breathe the toxins, they eat the fish, and they drink the water. But water toxic water that is irrigating crops that is later being distributed throughout the nation. And then you have cyanotoxins in your supermarket, in hundreds or even thousands of miles away. And so this is not a problem that is limited just, to the communities that are around these water sources. And these toxins are very, very potent. There's lots of studies, a dime a dozen that show how bad they are. They are related to all sorts of neurodegenerative diseases such as Parkinson's and Alzheimer's disease. They kill livestock that drink the water. In the United States, somehow they get very excited when dogs die when they drink the water. But all over the world, you have big animals, including cows and other animals that would drink a sufficient amount of these toxins and will die. And so just imagine if it can kill a cow, why can't it kill a human being, or definitely a child? It's a bad.
This may be strange, but has anyone tried to strain water with a whole bunch of cyanobacteria in it and cook it and make it into food? Or is it not possible to turn this into a food that actually would be good for you, even if you cooked it?
That's
or is
first
that
of all,
ridiculous?
It's not ridiculous at all. It's been tried. Cooking doesn't degrade the toxins. If you want to degrade the toxins, you have to chlorinate very aggressively. In order to get away with the toxins. The toxins are damn persistent. So cooking is not an option. Whether cyanobacteria is used as a food? Oh yes. There are species that are considered quote unquote non-toxic. One of the most famous ones is spirulina. They're being sold out as superfood. If you ask me, don't touch it. It's like introducing a vegetarian lion. I wouldn't go around it, even if they tell you that this lion is vegetarian. I would rather see it behind the bars of the cage. Look, there are so many species, and like I said before, they all release all sorts of metabolites into the water, and they've been around for a very long time. So the idea that a single species out of the bunch is non-toxic is, biologically speaking, not very convincing. And in fact, in recent studies have started finding also toxins within spirulina. In other words, stay away. I wouldn't touch it.
Well, very good. Well, Eyal, what's the best way for people to find out more and get in contact with BlueGreen?
So, first of all, if you want to find out more about the problem, it's all over the place. There's a lot of information with the US EPA, the WHO. There's a lot of information on our website, www.bgtex.com. And that's also the best way to communicate with us. We have representatives in the United States, in Israel, in South Africa, in China, in the middle of expanding, still a small Israeli company. But, we're trying to respond wherever there's a need. We're trying to be there. And like I said before, our ability to respond is relatively fast, and we can get to places quite quickly with a very effective solution.
Excellent. Well, Eyal, thank you for coming. I really appreciate it.
Thank you. Thank you very much for your time.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.